Are we ready? Make sure everything's set up here. Advent of Code 2023, Day 3 is called Gear Ratios. You and the elf eventually reach a gondola lift station. He says the gondola lift will take you up to a water source, but this is as far as he can bring you. You go inside. It doesn't take long to find the gondolas, but there seems to be a problem. They're not moving. Ah, what's that? You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. Because that's how engineering works. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number and should be included in your sum. Periods do not count as a symbol. Here's an example engine schematic. Okay. So these two numbers are adjacent to a symbol here, and this is adjacent to a symbol, and this is diagonally, but this is not, right? Because there's nothing around it. In the schematic, two numbers are not part of the symbol because they're 114. Oh, okay, yes, 114 up here. Got it. And 58 here, right? Their sum is 4361. Of course, the actual engine schematic is much larger. What's the sum of all of the part numbers in the engine schematic? Okay, so we just have to... All right, let's get the input. 2023, Day 3. It's 140 lines of input, and it looks like it wraps. Let's take a look at it here, because then, yeah. Well, it doesn't help. That doesn't make it any easier. All right. And I do, there's a bunch of ones with symbols and whatnot. Like here's 52 with an equal symbol and 909 with a percent symbol. All right. How do we want to approach this? All right. While I think about how to approach it, let's make our template. Oops. This way. Source, main. 3. 3 and 3. And we're going to build this out. 23, Day 3. Oops, I messed something up. Oh, I forgot to create the this thing here. There we go. Unsolved, unsolved. All right, so I think I want to approach this using hash sets. What we can do is, as we'll scan it row by row, character by character, and we can build the set of all of the spots around the number as we scan a number, and stick that in a number list. And then when we find a symbol, we'll stick that in a separate set. And then all we have to do is intersect the sets and to find out which numbers are close to symbols. What's part 2 going to be? I'm trying to... Sometimes it's a good idea to pre-think what part 2 could be, because you might want to design your code separately or differently, depending on whether or not you're just... But this one, I think I just want to say, let's say we have nums, nums. N-U-M-S is a vector of, let's call it these are just part numbers, right? A vector of part number, and then symbols is going to be just a hash set of all the locations. And I'll use I64s so I don't have to worry about negative numbers. So yeah, let's create a part number. And that's just going to have the value that's in the number plus a hash set of all of the values around that. So the value will be I64. and then we'll have, I don't know, points. Let's call it points, which is also going to be a hash set of the same thing we use for our symbols. And now we just have to build everything out, right? So we'll just step through step by step, character by character rather, and we'll just multiply by 10 and add the next character until we find the dot or the end of a line. Don't forget the end of a line. And then once we do, we'll save that in our vector here. And then if we see a symbol, we'll just save that in the symbols list. And then part 1 will just be looping over every number and see if its hash set intersects with any symbol. Yeah, I think that seems like a reasonable approach. So let's go with it. Let lines equals AOC lib read lines. Right? And then we'll say for row line in lines iter enumerate, for col ch in line chars enumerate. Now, unfortunately, these are U sizes, and I want to use I64 so I don't have to worry about negative numbers. So we're going to have a number. The current number, right, is going to start out as none. And then if ch is ASCII digit, then we see if we have a current number. So if let some, and we need a mutable reference. Here's what we'll do. Is before I do this, we're going to impl part number, and we'll have a new. And we'll give it a row, a col, and the current character. And this will return a self. And what we'll do is, for the first digit, because we don't know how many digits there are, we'll just do all of the surrounding values. Right? Ratian, thank you for the follow. Welcome. So over here, what we'll do is we'll set up a new points. Let points is equal to hash set from, right? And we'll just give it a list of all the surrounding points. So it'd be row -1 at col -1. Row, this is the left-hand side now, so we'll do col -1, and then row +1, col -1. That's the left-hand side. And then we'll do above us, row -1 and col, and row +1, col, right? And this is above and below. Suzuka 2023, thank you for the follow. And then we'll do the values to the right of us. So it'll be row -1, col +1, row, col +1, and row +1, col +1. Right-hand side. Right? And that'll be, oops, like that. And then, so we'll return a self with the value of ch as U8 minus 0 as I64, and then points. All right, so that'll allow us to create new numbers. But we also want to have a thing here where we can say if let some num is equal to cur number, right? If we can extract it, then we'll extend it. Otherwise, we're going to say cur number equals some part number new, row as I64, col as I64, and the character that we're going to start with. Right? And that'll give us our numbers. we just have to write this part now. So we need num dot add digit ch row as I64, call as I64. Right? And now we just need to write add digit. So fn add digit mod self and char. Doesn't return anything, and all we need to do is, what's this coming from? I'm going to ignore it for now. We need to add the digit. So in order to do that, we say self value is equal to self value times 10 plus ch as u8 minus b0 as I64. And now we want to add the right hand side again, right? Because we've added all the points around us. So say we just did the 6 through here. Now we're adding the 3, right? And now, so we need to add these 3 points next to us, because we don't know if there's another digit coming up. So we have to add the current point, which is fine because the symbol will never be in the same location as a digit. And then when we get to this 3, we can add these 3 points. And then when we get to the point, then we're going to do something else. And I haven't written that code yet. So we just need to steal these 3 values here and add them. Oh, can I do a hash set extend? Self points. I don't know if extend works on hash set. Oh, it does. Okay. Let's see that builds. Oh, that's where the missing paren was coming from. Okay. Consider giving current number a type. Okay. Part option part number. And then change this to be, oh, right, it has to be mutable. It's suggesting ref num or mute num. I think I need to do both, right? Because if I say mute, then it's going to say I need to ref it. Yeah, okay, so we'll ref it. There we go. Let's switch this back to run. Attempt to multiply with overflow. 72. Really? That's not a good sign. That's a bad, oh, I know why, because I'm not done yet. I'm not done yet. We have to finish. If we're not an ASCII digit, then we're going to say if let some num equals, right? We're not a number, not a digit, so that means there might be something here. So cur number take. And if we were able to take it out, it says unknown. That's a shame. Option unknown, but it's definitely an option part number. All right, if we're going to assume it worked. And we'll stick it in the nums list here, right? So we'll say self nums push num. And then we have to keep track of all the symbol locations that are not dots. So we're going to say if ch is not equal to a dot, we'll say self sims dot insert row as I64, call as I64. Right? And that should get them all. If I dump it out, it's going to be a lot of output. I don't know how I would even check to see if it's correct. We could take a quick look though. Debug out self nums. Oh, I could just do it on one thing here. And self sims. Part number doesn't, oh, I forgot to implement debug. All right, so we got something. Let's flip over to the input. and see. So this is at position 14. So 13, right? Because it starts at 0. So there should be 12 and 13. I see 12, 13, 14, right? So it should be 12, 13, 14, and 15 should all be in our set, and they are. And the value is 65, which is correct. Let's go down to the end of this mess and see if we make sure we got the last number as well. Wow, there's a lot of output. Okay, oh, I forgot a new line there. That's okay. So the last one looks like this guy here, 722. That's correct. And we're at line 140, so it's really 139. So we should have 138 to 140 for our rows. And looks like we should have, this is 134, 130. So 133. Yep. Okay. I think that's working. And then I'm going to assume all these are correct, because why would they be wrong? I wouldn't make a programming error, would I? Heaven forfend. All right, let's get rid of this print line because it's ginormous output. So now I think all we need to do, we have the set of all the points that the numbers are next to, and we have the set of all of the symbol locations. So part 1 becomes, we're summing up all of the part numbers that are next to what is the sum of all the part numbers? All right. How hard could this be? We'll loop over each of the numbers. We won't loop by symbol because the symbol could be next to more than one number, right? But if we loop over the numbers and then intersect that with the symbol hash, we should be able to determine if we have a number. So let's do that. Well, first, let's create a total. And that'll be our output. So we're going to say for num in self nums. Now we have the points. So we can say if num points, and then there's an intersection with num self sims. Is there an is empty? There is not. What's on here? This is an intersection. Oh, it only counts as an iterator. Is there a quick and easy way on an iterator to determine if there's anything in it? I could just say next. Yeah, I guess that would be the easiest way to do it, right? We can just say next is sum. Mohat says next is, yeah, so it's essentially what I'm doing, yep. So if it is sum, that means the number that we're considering right now does have a symbol next to it. So all we have to do now is total plus equals num.value, right? So we could actually do this as a filter. Let's do it this way, see if it works, and then I'll write it functionally. We have a number. That's the right answer. Okay, brilliant. 530495. Let's do this functionally. Let total equals self nums iter map, no, filter num, and it's just this, right? And then we just do sum. And that doesn't work because a type of I64 can't be made by summing a part number. I have to map it. I have to extract the nums value. There we go, 530495. Okay, so that's a functional way to do it. I always default to for loops over functional style because I am a C programmer, but I do try to do functional styles from time to time. So this works pretty well. Is this readable? Is this more readable than the for loop? It's definitely longer than the for loop was, right? If we take a look at the for loop, let's set that back to 0. Oop, there we go. Right? This might be easier to read for somebody like me. I'm going to commit this change. HG status git add dot git commit -m 2023 day 3 part 1, and then I'll do the functional style here that I just did and I deleted. Self nums iter, and then filter this thing here, map num value sum I64. And I forgot to put the thing there. There we go. So is that easier to read? I don't know. To me, this is more difficult, but other people might find it easier. And this is the functional way to do it. And Rust encourages functional style, I guess. Yeah. Well, let's commit this. More functional approach. All right. I'm distracting myself because I'm worried about what part 2 is. This could also be done functionally, but I think this would be way too complicated to do functionally. I would be happy to be proven wrong if somebody has a nice functional way to extract all this information. I'd love to see it. Mohad says, same for me. I always prefer classic procedural style of C, but I like to try different functional stuff with Rust. Yeah, I mean, this does the trick, right? You can see what it's doing. It's iterating, doing a filter on whatever the heck this is, and then you have to interpret that. Then you have to extract the value and then sum the values, right? Whereas with the iterative style in C, you just said total is plus equals this. So there might be a way I could just throw a function in here and then have, like, maybe there's I can do fn extract self I64 self value. Can I do that? And just say part number extract. Can I do that? Yeah, so that works too. And there might be something here I could also do. Except I'd have to pass in self sims, which means I can't do it this way, because I think this style requires that it only has a single argument, which is self, right? Somebody who knows Rust better than me can tell me. So I can say has symbol next to symbol. And I can do self, and I sims, which is hash set I64 like this, and it returns a bool, and it's just basically this one line. Right? Where did it go? Where did that one line go? Here it is. So we put that here, right? And put a self in front of it. And then up here, we can just say num next to symbol, right? So this is probably easier to read this way, if I can get it right. Oh, right, I'm supposed to put the sims in here. Like that. So now it's more legible in terms of reading it as in English. We iterate, we filter every number that's next to a symbol. We extract the part number, or extract the value. I should call that extract value, right? And then sum them all up. Yeah, I think I'll go with this. Git commit a bit more legible this way. All right, enough distractions. Enough distractions. Let's continue to part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend to the water source. You don't seem to be going very fast, though. Maybe something is still wrong? Fortunately, the gondola has a phone labeled help. So you pick it up, and the engineer answers. Before you can explain the situation, she suggests that you look out the window. There stands the engineer, holding a phone in one hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. One of the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 part numbers. Its gear ratio is the result of multiplying these 2 numbers together. Okay, I'm just getting hung up on ratio and multiplying. I shouldn't go. Ignore it. I'll just keep going. This time, you need to find the gear ratio of every gear and add them all up so the engineer can figure out which gear needs to be replaced. All right, so in this schematic, there are 2 gears. First is in the top left with these 2 numbers. I see it. So this is next to 2 numbers. The second gear is in the lower right, and it has a gear ratio. The star adjacent to 617 is not a gear because it's only adjacent to 1 part number. All right. And what is the sum of all the gear ratios? Got it. Mahad says somebody else highlighted. Yeah, I'm sure I'm not the only nerd who's a stickler for language. All right. So let's do gears, which is going to be another hash set. And it's going to be a subset of sims, right? So we just need to say this here. If ch is equal to gear, then we'll do this. Now, how do we use that? Let's go to part 2. And all we care about is the gears now. So we're going to flip this on its head. And I'm going to write it in C style first, and then we'll do it functional if it makes sense to do so. So we're going to set a total. We're going to loop over all the gears. And now I'm happy I made that is next to thing, or next to symbol thing, because I can just reuse that. For gear and self gear, we're going to loop over each of the numbers. If num next to symbol. Oh. Yeah, we can just do it. We can do it this way, right? Oh, yeah. I want to count up how many there are. So I can just do this. Contains num points, contains gear. Gear is probably already a reference, right? Geert. It is a reference. Okay. Then why is points not giving me what I want? Isn't num? Why is that giving me that? Is it because I did close that? There it is. Okay. Yeah, okay. If the num points, then what we'll do is we'll push it onto a vector. Let mut matches equals vec new. And then we'll just say matches push num value, right? We can do, we can go a little bit further and say if matches len is equal to 2, then we're about to push a third and we don't care about the third. So we'll continue to the next gear. Right? And we push the number, we push the value. And then down here, we can say if matches len is equal to 2, then we're going to add to the total matches of 0 times. Thank you, D. Scott Boggs. Thank you for the follow. Welcome. Times matches of 1. And then we just put the total here. All right, this is the C style, not the functional style. And we come up with a very large number, as one might expect when you're multiplying 3-digit numbers together and adding them up. And we got the right answer. Nice. Ooh, look at this. This must be the island that we're on. And this must be like the gondola thing. I'm not sure what this is. This is like a little tent, maybe. So it's the trebuchet from day 1. Oh, interesting. I didn't notice that before. 4 is up here. Yeah, so we're going to be coming back down, maybe. We'll go up for a few days and then we'll work our way back down. We'll find out.